So I want to take just a moment to define what a parametric equation is. If you look in your book, this is the definition that your book would give you. This is not something you need to write down, especially the definition, as long as you understand what we just did. But a parametric equation, or a system of parametric equations, notice that it's plural because we have two equations. We have x as a function of time. We have y as a function of time. So f and g are different functions. And so then we have the set of points that are given by f of t comma g of t, and those depend on the parameter t, so over an interval of t values. So some terminology that you do need to know, and you might want to write these down if you think you might forget them. In parametric equations, we're going to use what's called a parameter. That's why we call them parametric equations. And the parameter is a variable that the coordinates depend upon. So the x-coordinate depends on t, the y-coordinate depends on t, but notice that the x and the y don't depend on each other. The value of y doesn't depend on what the value of x is, the value of x doesn't depend on what the value of y is. They both depend on a different variable, and we call that variable the parameter. The parameter interval is just the interval on which t lies. So in the last example, the parameter interval is 0 to 9. The initial point is just the starting point, so it doesn't necessarily have to be the left point in our graph, but it's going to be the left point, and I put left in quotation marks because there is no left and right when it comes to t, because there is no t, there's no t-axis, but it's the lowest value for t. So if you plug in the lowest value for t, whatever point you get, that's your starting point, or your initial point. And then your terminal point, it's where it terminates, is your ending point.